All right. Hey, everybody. You guys got your quiz on Monday, so let's go over the review. This is the review I gave you guys on Friday. Don't forget, you still have to do your homework from the homework packet, and you've got to do the other packet that I gave you too, where the cover talked about bear, quadrilateral oh my, and quadrilateral wizard, etc. So you've got a lot of homework. I don't think it's too much. I think it's the right amount if you've been doing it like you were supposed to. But do those practice problems. That way when you come in Monday, you'll be ready to go. All right. But grab the packet that I gave you, and let's run through the first problem. And I think we did this one in class, so if you already know this one and you're comfortable with it, just fast forward to number 2. So how do we do this? Basically, for every single question on this quiz, you guys are going to want to start by finding the lengths of sides, and usually you want to find the slopes of sides too. If you're classifying a quadrilateral, then the slopes are important. But we're classifying a triangle here, so the slopes are not that important, so I'm going to dive right in and just find the lengths. And to find the length of a side, we said we pretty much always want to be building these little right triangles on the sides. And then you can just count squares. I see 1, 2, 3, 4 squares. And from here to here, this is a lot of squares. I'm not going to count them. Instead, I'm going to use the x-axis and see that this guy starts at -6 and it runs all the way to 4. That's a length of 10. So rather than counting all the squares, I can just do that. So now we know that the length of AB from the Pythagorean theorem will be the 4 squared plus the 10 squared. And then you take the square root of that. So that's going to be 16 plus 100. Take the square root of that. So the length of AB is the square root of 116. And I don't really want to even know what this is as a decimal. You just leave it as the radical. And if you get another square root of 116, you know they're the same. If you get some other number, you know they're different. And for our purposes, that's all we care about, is are the sides all the same? Then we're equilateral. If 2 of the sides are the same, then we're isosceles. And if none of the sides are the same, then we're scalene. All right, so let's go to the next side. That would be side BC. So I build a little right triangle on it. I can see this horizontal length goes from -2 to 4, so that's a change of 6. We go from -3 up to 4, so that's 7. So that means for side BC, we're going to be 6 squared plus 7 squared. That's our length. That's a 36 and a 49, which makes a 85. So our length is the square root of 85. So far, 2 of our sides are different. That means we're definitely not equilateral. But maybe this third side looks short. I'm definitely getting scalene vibes off of this thing. But you do your math anyway, because if this side somehow turns out to be root 85 also, then you'll be isosceles. So let's just do the math and see. So from here I'll drop down, from here I'll run over. I see 1, 2, 3, and I see 1, 2, 3, 4. I'm going to sneeze, hold on. Alright, I'm back. So for AC, you just do 3 squared plus 4 squared. That's a 9 and a 16. That adds up to square root of 25. Now the square root of 25 comes out cleanly, so do it, and you get exactly 5. But that does mean that since all 3 sides are different, this triangle is a scalene triangle. Now they want you to decide if the triangle is a right triangle or not. And that's what Ms. Lee is asking, is it right or not? And she's asking that because she would have you guys use slopes. And if the slopes are opposite reciprocals, then the sides are perpendicular, and that means you have a right angle. But I think you guys can do better than that. I think you guys can actually classify it as right, acute, or obtuse. And I think everybody's written this down by now, but we'll write it down one more time. We said if the 2 short sides, meaning A and B, if you take them, square them, add them together, if those things end up equal to the longest side, which is C squared, then the triangle is right. And then of course the only other options are, what if a squared plus b squared was less than c squared? Or actually a better way to think of this is, what if c squared was bigger? Then that makes an obtuse triangle. And if a squared plus b squared is bigger than c squared, then the triangle is acute. So that means you take all your side lengths. Now our biggest side length here is the root 116. So take that root, oh, you can't see behind my face. So we'll, oh no, oh boy. Hold on, move my face. All right, there you go. So we're gonna take the root 116 and square it. And remember, when you square a radical, the radical just gets canceled out. So you literally just get 116 as your answer. And what we want to do now is compare that to the other sides. So take the root 85 and square that. And then add to that the 5 squared. So that's going to be a root 85 squared is normal 85. And a 5 squared is 25. But adding that up only gives us 110 versus 116. So comparing those values, we see it's the 116 that's bigger. So that definitely puts us here, where c squared is the bigger thing, which proves that our triangle is obtuse. And that's it. So for these questions about triangles, it's pretty simple. You're just going to find the length of all three sides. If they're all the same, you're equilateral. If only two are the same, you're isosceles. And if none are the same, you're scalene. Then take all your side lengths, take the very biggest side and square it. Then take the other two sides and square them and add them together. And if the two numbers you get are the same, then you're a right triangle. But if c squared is bigger, then you're obtuse. And if c squared is less, then you're acute. That's it. So looking at the next question, number 2, you should probably take a minute and actually do this one yourself. If you haven't, make sure you can actually do it, get a little practice in. But I'll explain it in a second. Hopefully you'll do it first. Put my face down there. All right, so go do this question, and then I'll do it with you. All right, so to do this question, we're going to do the same thing we always do. I'm going to put right triangles around everything. I can just do that real fast by going like this. Just put a big rectangle around the whole thing, right? And then let's see what I get for sides here. Up top, we've got this one right triangle whose leg here, it's only 1 unit long. And then the top goes from 6 all the way down to -9. So that's 15. So we've got a 15 by 1 right triangle. Then over here on the right hand side, we go from -2 over to 6. So this horizontal piece is 8. And the vertical piece from 3 down to 4, that's 7. Then on the left, we're at a height of 4, going down to a height of 4. So this vertical guy is 8. And then 9 over to 2 is 7. All right, so like you might have suspected, just by looking, these two purple sides, this is the hypotenuse of an 8 by 7, and this guy's the hypotenuse of an 8 by 7. So even without doing the math, you can tell that those two purple guys they're gonna come out the same. This triangle is gonna be isosceles, but do the math anyway, because you have to. So let's get going on that math. And we'll start with DE anyway. So DE is going to be the square root of 15 plus 1, or 15 squared plus 1 squared. So that's 225 plus 1. So that's going to be the square root of 226. Then DF will be the square root of the 8 squared plus 7 squared. So 64 and 49, which is 113. And then in blue, we're going to get the same thing. That's going to be EF. You're doing the same two numbers, a 7 and an 8 squared. So of course you're going to get the same two numbers, 49 and 64. So of course you're going to get the same sum, which is root 113. So there's the work that really proves that we're isosceles. We can see we've got the two sides that are the same. So now, are we a right triangle, an acute triangle, and an obtuse triangle? This one's a little tricky because how do you, well, whatever. The 226 is obviously the biggest, so that has to be C for us. Then the two smaller ones will be our A and our B. So let's check. A squared plus B squared would be root 113 squared plus root 113 squared. And then we're going to check and see how that relates to the 226 squared. So this is 113 plus 113, which is, guess what, 226. And root 226 squared is 226. So guess what? Those are equal. So that proves that the triangle is a right triangle. So when Ms. Lee asks, is it a right triangle? You'll say yes. Or if I asked you, is it a right triangle, an acute triangle, and an obtuse triangle? You'd say it's a right triangle. This guy's a right triangle for sure. Anyway, let's leave triangles alone now and start tackling some quadrilaterals. I've got good news for you. Ms. Lee has decided that you guys are going to get this grid, this one here, not the one below it, but you're going to get this grid on the quiz. So you're going to know that a parallelogram is the one that has to have two pairs of parallel sides. You're going to know that to be a rhombus, you need those parallel sides, but you need all four sides to be the same. To be a trapezoid, you only need one pair of parallel sides, and that's it. To be an isosceles trapezoid, you need one pair of parallel sides, and you need the non-parallel sides to be congruent. To be a kite, you shouldn't have any sides that are parallel, but you should have two pairs of congruent consecutive sides, or adjacent sides. And to be a square, you've got to have those consecutive sides that are perpendicular, so you need the right angles, and you need all four sides congruent. To be a rectangle, you'd need your consecutive or adjacent sides to be perpendicular, giving you the right angles, but you'd also need to have only two pairs of congruent opposite sides, meaning they can't all be the same. Okay, so you're going to have that list, which should take a little pressure off. You don't have to study quite as hard to memorize all of the different quadrilateral properties. You're going to have them. Okay, what you won't have is this little flow chart, and I think this flow chart helps. So I think as I do problems, I'm going to refer back to this flow chart. I gave this to everybody for the most part, but on ours, it didn't say all four sides congruent. Ours talked about, are the diagonals perpendicular? And I don't like that. We've been using whether the sides are all the same as our condition, so maybe make a change on that if you didn't already make that change. Okay, let's go do a problem. Number 3. So these things are misnumbered too. I don't know if you guys changed your numbers, but this first number 4 should really be number 3. So that's 3. Then the next thing is marked as 4 and it really is 4. Then this is 5 and it really is 5. This is marked as 4 but it ought to be 6. This is marked as 3 but it should obviously be 7. And the very last problem on our packet wasn't marked at all, and it should be 8. So I'm going to go through all these problems, and then the video is going to be over. Hopefully by the end of this packet you'll know everything you need to know anyway. So take a look here. It says classify quadrilateral walt, where your slopes are a quarter, -4, a quarter, and -4. So where's my little cheat sheet? This guy. Alright, so what's it say? It says start by finding the slopes. Well, we've got the slopes, and we can see that we do have two pairs of opposite sides that are parallel, the 1/4 and the 1/4, the -4 and the -4. So that means These are out. We can't be an isosceles, trapezoid, a kite, or a quadrilateral. This whole side of the board is out. We're over here. It says the next thing to check is, are all four sides perpendicular? Now they don't mean to say that. They really mean to say, are all four pairs of adjacent sides perpendicular? But for that you look at the slopes and you would say, are these opposite reciprocals? And yes, they are. Then is the -4 opposite reciprocals with the quarter? Yes, they are. Is the quarter opposite reciprocals with the -4? Yes. And then is the quarter on the top opposite reciprocals with the -4 on the bottom? Yes. Do you see 4 pairs of opposite reciprocals? So do I. So that means I do have 4 right angles. And that means that we're coming down this path. And that means we're not coming down this path. So we're not a parallelogram, we're not a rhombus. So finally, the question to ask is, are all 4 sides congruent? And they are. 5, 5, 5, and 5, right? So that means we're a square. A rectangle wouldn't have all the sides the same. A rectangle would be like 5 and 15, and 5 and 15. There'd be 2 that are different. So rectangle's out, we're a square. But that should be your thought process as you do all these problems. Think about how many pairs of parallel sides do I have? Then, are my sides perpendicular, giving me right angles? Then, are all my sides congruent? Yes or no? That's it. That's the process here. So clear annotations. We just decided for this problem we're a square. Now let's try the next one. Reorder to the top. All right, so let's do it again. This time what do you see? I see a half, negative a half, 4/3, negative 4/3. None of those are parallel. So it can't be a square or a rectangle or a rhombus or a parallelogram or a trapezoid or an isosceles trapezoid. We're on the no parallel sides region of our table. So it can only be a kite or a quadrilateral. And looking here, we've got the 2 pairs of congruent sides. But instead of being across from each other, they're next to each other. So that means I've got a side and a side here that are the same, 3√5 and 3√5. Then I've got the 10s that are here and here. And that makes us a kite. So quadrilateral's out, we're a kite. That's it. That's this is supposed to be number 3, right? So for 3A and 3B, we were a square and a kite. Moving on. Too big. Shrink. All right. What about this? Wait, is that the same or different? Looks kind of the same. 1/4 and 4. All right, not the same. So what do we got? We've got slopes that are the same and slopes that are the same. So those opposite sides are parallel. So we're definitely coming down this side again. So we can't be that or that or that or that. Now, are the sides perpendicular though? No, because these adjacent sides do not have slopes that are opposite reciprocals. So that means we don't have right angles. That means square and rectangle are out because we're coming down this branch now. And we're either a rhombus or a parallelogram. Again, a rhombus would have all of its sides the same. So at this point, you just check to see if all the sides are the same. And they are. It's 5, 5, 5, and 5 again. But we're not a square this time because we didn't have the right angles. So that means we must just be a rhombus, not a parallelogram. So we're a rhombus. And then for part B, same deal. Doesn't quite fit, does it? Okay. So looking at our slopes this time, I've got 1 pair of congruent slopes, the 2 and the 2. Then the other 2 are different. So that immediately tells me we're coming down the middle of our chart, and we're going to be a trapezoid, either a trapezoid or an isosceles trapezoid. Kite's out, quadrilateral's out, 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 out. All right, so what's the differentiating factor between a trapezoid and an isosceles trapezoid? It says, are the lengths of the non-parallel sides congruent? Well, the non-parallel sides, let's see, these are the ones that are parallel, the ones with slopes of 2 and 2. So the non-parallel sides would be AN and FT, and oh, would you look at that? They are congruent, 3 root 5 and 3 root 5. So that means we do fall squarely in the isosceles trapezoid camp. And that's it. We're not just a trapezoid, we're an isosceles trapezoid. Got it? Hope so. Moving on. So now we get to the problems where you have to do the math yourself. You have to find all the side lengths yourself, which is fine. To do that, we just build a big box around the thing like before, starting at point F. I'll just go bzzz, make sure a side goes through E, a side goes through D, and I can build right triangles everywhere. And then I just go after this. Let's find our slopes first, actually, because we're dealing with quadrilaterals now. So in alphabetical order, let's go DE. We're going to find the slope of DE, and then EF, and then FG, and then DG. So DE is this guy, and we can tell that line is increasing. See how as I draw it from left to right, it's going up, up, up? So I know this slope is going to be a positive slope, as opposed to EF. EF is a line that's coming down, down, down as I read it left to right. So I know EF is gonna have a slope that's negative. Without even doing any math, I already know. It's gotta be negative because it comes down. DE has gotta be positive because it goes up. DG is coming down, so it's gotta be negative. And then there's something special about FG. FG is horizontal. So I know that because it's horizontal, why can't I spell? Because it's horizontal, its slope is going to automatically be 0. So if you just want to put 0, go ahead. You don't have to show any work. You don't really have to show work for any of these slopes, except when you have to reduce the slopes. So where are we on DE? What's our rise? We're going from -4 up to a height of 4, so that's 8. Then we're going from -8 over to -2, so that's a change of 6. Now rising 8 and running 6, that's both positive, and we always do rise over run. So it's got to be 8 over 6. I can divide both of those by 2 and I'll get 4/3. So 4/3 is my slope, and it's positive like I want it to be. Now for EF, we're going from 2 to 4, so that horizontal change is 6. But then I'm going from 4 all the way down to -8, so that's a change of 12. Technically I went down, so it's -12. So this is -12 over 6, which is -2. And it came out negative, like I wanted it to, so I don't have to mess with it. Now for DG, we're going down 1, 2, 3, 4, so -4. Then we're running 2 to the right. So that's -4 divided by 2, which is -2. So now looking at these slopes, just like in the past problem, I see only 2 slopes that are the same. That means only one pair of sides are parallel. Oops, that was terrible. One pair of sides are parallel. And that makes us a trapezoid. But we might be an isosceles trapezoid, right? So we are now supposed to check the length of GF versus DE. Maybe those two lengths are the same. They actually look kind of the same to me. So the good news is you can find GF really easily because you just count the squares. Now G is at -6 and F is at 4. So that definitely is just a length of 10. So the measure of GF is 10. And I don't have to show work for that because I'm just counting squares. Now to find the measure of DE, here I better show some work. Because I'm using my right triangle. I'm going to use the 6 and the 8. We're going to go 6 squared plus 8 squared. So 36 plus 64, square root of 100, that's 10. So guess what? After all this work of finding the slopes and finding the side lengths, I can now proudly say that this is not simply a trapezoid, it's an isosceles trapezoid, because these two green sides are the same, 10 and 10. So it is an isosceles trapezoid. And that's because it has one pair of parallel sides, that makes it a trapezoid, and its two non-parallel sides are congruent. That makes it an isosceles trapezoid. And we knew that the sides were parallel because their slopes are the same. Two slopes were -2 and -2. That made us parallel. Okay. All right. I know this video is going to cut off because my program always cuts off around 30 minutes. I might just cut it off now rather than getting cut off in the middle of a problem. Can I do a whole problem in 5 minutes? Let's find out. All right, let's do 6. I think I could do this in 5 minutes. Should be a simple one. Because what are we going to do? We're going to build a little rectangle, aren't we? And that's going to form our big bunch of triangles. So we can see at one corner, we're going to build one right triangle that will allow us to find the length of AB, or really what we're after is the slope. But it's 1, 2, 3, 4. And then it's 6 to 6. So this is 12. So let's find the slopes first. And the slope of AB, we just saw that we rose 4 and ran 12. That's a slope of 1/3. Then we'll go after BC. And for BC, you can see that we're running 2, and then we're rising 1, 2, 3, 4, 5, 6. But we're going 6 down. I think I just said that backwards, by the way. But we're rising the -6. That goes in the numerator. We're running +2. That goes in the denominator. So that's a slope of -3. So you should know something about that, by the way. These numbers are opposite reciprocals. So that actually just proved that angle B was a right angle. So if you guys were thinking this was a rectangle, it might be. We've got one right angle so far. Let's see if we can prove that all the others are also right angles. So we're on to DC now. And I usually like to go left to right. So if I'm going from D running over to C, that's a change from 4 over to 8. So that's a change of 12. Then it's a change from 7 up to 3. That's a change of 4. So for DC, 4 over 12 is the third. So two things just happened. We just proved that the two sides with slopes of a third are definitely parallel to each other. But we also just proved that this 1/3 and this -3 are perpendicular, so that proves that angle C is another right angle for us. Then we got one more to go. So let's do AD. And from A to D, we can see we're rising down 6, so -6. Then we're running 2. So AD is going to have a slope where the rise is -6, the run is 2. So that's a slope of -3, which again proves two things. We now have -3, so the slopes are the same, proving that AD and BC are parallel. It's also the opposite reciprocal of the 1/3, so that makes this a 90-degree angle. And then that -3 is also the opposite reciprocal of the 1/3 up here for AB, giving me another right angle. So we definitely have all the information we need already. Well, I lied. We don't actually, because having 4 right angles doesn't necessarily make me a rectangle. I mean, we are a rectangle. But you do have to prove that we're not a square, right? And to prove that we're not a square, you'd have to find some side lengths. So you better check some lengths. And if you want to be lazy about it, then you don't really have to find all 4. You really would just have to check 2 adjacent sides. Because if the adjacent sides are different, then you would know you're a rectangle. So I'm going to just do AD and AB. And as soon as they're different, I can say I'm a rectangle. So let's start with AB. Make sure you use the numbers before you reduced. Don't use 1 and 3. Use the 4 and 12 because those are the actual side lengths of the triangle. So I'm going to go 4 squared plus 12 squared. That's going to be 16 plus 144. That's going to be the square root of 160. So that's AB. Now just do AD. And for AD, use the 6 and the 2. And remember, I don't really care about the -6, because -6 squared is going to be positive 36, just like 6 is. So you don't really have to worry about the signs. But 2 squared is 4, so I'm getting root 40. So those are definitely different. So you can say this thing's a rectangle because it has 4 right angles. But not all of its sides are congruent. So I kind of had to do two things here. I had to say why it was a rectangle. It was because it had 4 right angles. But I did also have to say why it was not a square, meaning not all of its sides are congruent. You do have to do that. You have to tell me what it is, but you also sometimes have to justify why it isn't something else, something better. So hopefully you understood what I just said. This video is going to cut out, so I'm just going to end it. See you all in part 2.